Across the vast cosmic canvas, an unseen force orchestrates the dance of galaxies. This is dark matter, a mysterious entity accounting for roughly 27% of the universe's mass energy content. Its gravitational grip is undeniable, shaping the largest structures, yet it remains imperceptible to all direct observation, a silent architect of the cosmos. The void whispers of its presence through the warping of space-time and the accelerated rotations of galactic disks. Without dark matter, galaxies would tear themselves apart, but its true nature eludes physicists, a fundamental enigma at the heart of modern cosmology, hinting at profound, unknown physics. Consider an audacious hypothesis. What if dark matter is not merely an exotic particle, but the skeletal remains of a previous, entirely distinct universal system? A dead universe, its energetic process is concluded, leaving behind only the inert, gravitationally potent residue of its former existence. This theory suggests that our current universe, with its vibrant stars and complex chemistry, might be emerging within or alongside the decaying structures of an older cosmos. The gravitational influence of this ancient system would persist, acting as an unseen scaffold upon which new galaxies coalesce. If dark matter represents a defunct universe, its properties become more explicable. Its non-baryonic nature and lack of interaction with electromagnetic radiation would be consistent with a system whose primary energy and matter interactions have ceased, leaving only fundamental gravitational fields. The death of such a universe could involve a slow, inexorable expansion and cooling, leading to a state of maximal entropy where all complex structures have decayed into simple, stable components. These components would no longer emit or absorb light, yet retain their mass. The lingering gravitational potential of these dead constituents would permeate our observable universe. Imagine an expansive, frozen ocean, its currents long stilled, yet its sheer mass still affecting the tides of a newer, warmer sea that now flows over its ancient depths. The death of a universal system, in this context, implies a state of ultimate thermodynamic equilibrium. All stars would have long since extinguished, black holes would have evaporated through Hawking radiation, and matter would have dispersed into a homogeneous, ultra-cold expanse. Energy gradients, the drivers of complexity, would cease to exist. Within such a defunct universe, any remaining fundamental particles or exotic matter states would have settled into their lowest possible energy configurations. They would be inert, stable, and incapable of further interaction through the strong, weak, or electromagnetic forces. Only the fundamental curvature of space-time, gravity, would persist. This pervasive gravitational residue would act as a cosmic framework. Our baryonic matter, born from the Big Bang of our own universe, would then condense and flow along the pre-existing gravitational wells established by this ancient dead system. It provides the hidden scaffolding for our cosmic structures. Galactic halos, the vast, invisible envelopes surrounding visible galaxies, are precisely where dark matter concentrates. If this dark matter is a dead system, these halos represent the densest gravitational remnants of its previous existence, dictating the shape and dynamics of every galaxy within our current epoch. The cosmic web, the largest known structure in the universe, consisting of filaments of galaxies interspersed with colossal voids, would find its origin in this hypothesis. The dead universe's relic density fluctuations would directly translate into the large-scale gravitational landscape we observe today. This interaction is primarily one-sided. Our vibrant, energetic universe is shaped by the inert gravitational influence of the dead system. The dead system, having exhausted its own energy, remains largely unaffected by the energetic processes unfolding within our younger, more dynamic cosmos. The absolute silence emanating from dark matter is a crucial clue. It neither emits nor absorbs light across any spectrum. This absence of electromagnetic interaction is consistent with a system that has run its course, where the mechanisms for producing or responding to photons have long since ceased. The stability of dark matter, its seemingly unchanging nature over cosmic timescales, further supports the dead system hypothesis. If it were still actively evolving or interacting, observable signatures or decay products would likely be detected. Instead, it persists as a static, gravitational anchor. The uniform distribution of dark matter at cosmic scales, yet its clumping in halos mirrors the expected outcome of a highly evolved, gravitationally collapsed system. Initial irregularities would have smoothed out, leaving behind dense pockets where matter once gathered, now only a gravitational memory. Consider the immense timescale involved. A universe reaching thermodynamic equilibrium would require trillions upon trillions of years, far exceeding the current age of our universe. This previous system would have been unimaginably ancient, its processes long complete before our own began its nascent journey. The interaction between our universe's baryonic matter and this dead system's dark matter is analogous to a river flowing over an ancient, submerged mountain range. The water, representing baryonic matter, is guided and shaped by the unseen topography of the mountains, which represent the dark matter. On Earth, gravity governs the fall of an apple. It is a localized, relatively weak force compared to others. In the cosmos, dark matter's gravity operates on scales incomprehensible, bending light around entire galaxy clusters, a phenomenon known as gravitational lensing, revealing its immense pervasive influence. Unlike the visible universe, where stars shine and galaxies collide, the dead system would be a realm of absolute inertness. No light, no heat, no chemical reactions. It is a silent, cold, and massive blueprint of what once was, now merely a gravitational phantom shaping the emergent cosmos. Our instruments, designed to detect energetic interactions or electromagnetic radiation, are inherently blind to the dead universe. Just as a sound detector cannot perceive light, our current technology may be fundamentally unsuited to directly observe the inert, non-interacting remnants of a past cosmic epoch. The collapse of such a previous universal system would not be a violent implosion, but a gradual, inexorable entropic decay. Over eons, all matter would dilute, all energy gradients would flatten, leading to a universe indistinguishable from absolute vacuum, save for the persistent curvature of space-time. This entropic death would represent the ultimate failure of stellar nucleosynthesis, black hole accretion, and all forms of energy transfer. The dead system would have reached its cosmic heat death, leaving behind only fundamental gravitational fields and perhaps super-heavy, non-interacting particles. The implications for our own universe's ultimate fate are profound. If we are emerging within the gravitational shadow of a previous dead system, does our trajectory inherently lead to a similar end? Is our cosmic dance merely a transient flicker upon an ancient eternal stage of gravitational residue? However, even a dead system might undergo subtle, slow changes. The evaporation of primordial black holes within this ancient system, though occurring over unfathomably long timescales, could contribute to a slight, imperceptible decay of the overall dark matter density, a whisper of its ongoing transformation. Could minute gravitational waves originating from the final, gargantuan mergers within the previous universe still ripple faintly through the dark matter medium? These extremely low-frequency waves would be echoes of an epoch long past, potentially detectable only with next-generation observatories. The collapse or cessation of all active processes within the dead system is its defining characteristic. It is a universe where the forces of creation and destruction have played out completely, leaving only the fundamental consequence of mass, its gravitational pull on all that exists. This hypothesis positions dark matter not as an exotic ingredient in our universe, but as the fundamental substrate upon which our universe is built. The collapse of the old system defines the boundaries and structures of the new, a cosmic inheritance of gravity. The universe, in this grand cosmic narrative, appears less as a solitary entity and more as a multi-layered tapestry woven from epochs. Our vibrant, energetic reality might be but a new bloom in a garden of ancient, silent, gravitational ghosts, a constant cycle of cosmic renewal and decay. Humanity's perception of existence is inherently limited to the baryonic matter and energetic interactions we can detect. To consider dark matter as a dead universal system forces a re-evaluation of reality itself, extending it beyond the observable into the realms of the unseeable, yet ever-present. This theory challenges the conventional understanding of a single continuous cosmic evolution. Instead, it posits a layered cosmos where the relics of one existence become the foundational elements for the next, an infinite recursive loop of universal birth and death. The sheer scale of this possibility dwarfs human comprehension. To exist within the echoes of a prior universe implies a profound humility, acknowledging our reality is not entirely self-contained, but intrinsically linked to an unimaginably vast primordial past. Such a cosmic blueprint suggests that the seemingly empty vacuum of space is not truly empty. It is saturated with the gravitational memory of an earlier epoch, a silent, pervasive presence that silently dictates the ultimate fate and structure of everything we observe. The search for dark matter becomes, then, a quest to uncover the archaeology of existence itself. It is a pursuit not just of a particle, but potentially of an entire cosmic history, revealing the universe as a continuous, cyclical phenomenon rather than a singular event. If dark matter is indeed a dead universal system, a silent, gravitational ghost of a bygone era, what implications does this hold for the future of our own universe and the fundamental nature of time and cosmic recurrence?